Continuing our exploration of annuities where we add more and more money to our account instead of just watching it grow with a percent interest. We're now on page 111. Amy is 25 years old. She wants to start thinking about retirement early. Good for her. She plans to invest in a 5% interest compounded annually. She's going to save $100 so that she can make annual payments of $1,200, so $100 for 12 months. And we want to determine the future value because she's going to do this for 35 years. So from all of that, we know that we can fill in our solver here. So she's going to have one compounding period a year for 35 years. That's N times T. She found a 5% interest. No principal here because her regular payment is going to be $1,200 every year. Future value, that's what we want to look for. Payments per year, one payment per year, and that interest is going to be compounded one time a year as well. And because this is annuity, she needs to have some money in there to start. So we're going to have her invest that $1,200 to start. So on her calculator, remember we got here by going to apps, number one, finance and solver. So we have 1 times 35 for our total number of compounding periods, 5%, negative 1,200. So remember that's negative because she's giving that money to the bank, putting that into her savings account there, or her annuity account. We want to go find that future value. If you have a different number there, if you have 0 there, you can leave it there. That's fine. PYCY 1 and 1 and begin. So we go to FV and we hit alpha enter to solve. And so she'll have just over $100,000. So Amy, let's write a sentence for that. Will have $113,803.59 in her account after 35 years. That's not a bad amount of money to have after 35 years. However, her financial planner says that they recommend $850,000 for retirement. So will that cover it? No, it needs $113,000. That's less than $850,000. So what can she do? Well, she can increase the number of times her account is compounded. She could increase the amount of time she can invest for a longer amount. She could find a higher interest rate. And what else could she do? She could increase the amount that she is saving every year, month. So if we increase any of those, all of those, then that could only help. Sorry about my dog. So she goes out and she finds something a little bit better. So it's now compounding monthly. We're on page 112 here. She's now compounding monthly and it has monthly payments. It's got a 6% up from 5%. She increased from 35 years to 40 years. And we want to figure out how much we need to determine the monthly payments that she needs to make that amount of money. So now her little n, the number of compounding periods per year, is now monthly, so that's 12. She's doing that for 40 years now at a 6%. Again, no principal value because she is making, well, we don't know what she's making payments into her account yet. We got to figure out how much she needs to invest each month to be able to reach her goal of $850,000. She is putting in those payments and the compounding period is monthly now. And then since it is annuity, we will go to begin. So back to our solver. Should already have it pulled up on your phone or calculator. 12 times 40 will do that calculation for us. It looks like she's making 480 monthly investments, 6% interest rate. We're going to go find the payment to get a future value of $850,000. 12 and 12 for PYCY, and we want begin because it's annuity. We want to calculate how much she needs to invest. All right, looks like with all that, she needs to invest that much a month, which is up from the $100 a month that she was doing. So that is $424.69. So Amy will need to invest $424.69 a month for 40 years to be able to have saved $850,000. So this is better than if she just like put in that much money. We saw a few pages before we were talking about how to save up to $1 million. This is page 101 here. That she would have had to invest $113,000 to have $1 million after 40 years. So here she's splitting it up and she's just investing $400 a month to be able to have saved up enough for her goal for retirement. See you in the next video.